I can? Okay. So, okay, I will start. So, hey, shh, let me talk now. It's my fault. I know I started. Okay, I need to stay here. They told me don't go around. So stop to just jump all the, all the intro. And the agenda will be, I will do a small step back just to let you understand my mentality and how I try to approach things, and then why we use hash join and what kind of test baseline I build up, and then the test between different distributions for hash join, and then my personal consideration. Can you hear me on the back? Yes, perfect. So these numbers come from a city that is somewhere in an island that is not part of Europe anymore, which is London. And okay, I was trying to figure out some statistics, and actually London was the only one giving me quickly some numbers. And we have 10 million people, and we have 60,000 different streets that are reported so far. That's what they said, and 30,000 different professions or work categorization. And as a human being, if I think I want to know who is a physician in that specific building that is in front of me, I realize I just picture in front of my eyes someone, so people that is living in front of me, and these are physicians, right? Something like that. Now, how a remote database, relational database works is totally different, right? You try to optimize what it is looking for based on the information it got by each table and by the number of rows. So it's trying to optimize the things. So for instance, we can have a plan saying, let's start with the streets, and so we have one street, one address at the end. And then identify all the people living there, let's say 40 people living in that specific building, and at the end, how many physicians we will have, just one. And that is a possible plan, right? Another plan that looks like very similar, actually if you check, the first one is starting with more rows number, the second one starts with less number, with less rows. Say, okay, no, let's start with the professions category, right? And see how many professions are you looking for. So filter for profession, I am looking for physicians, so one row. Then filter the 10 million people, and then at the end filter for the address. Now, those two things looks like very close and quite the same, but they are not. If you use an index on the different tables and you do the calculation, the first plan will result in more or less in 10,000 rows lookup. I mean, it will look for 10,000 rows, while the second one will look for 600,000 rows. If we remove the indexes, the scan will cost us 10 million rows in the first plan, and then 17 billions for the second one. I think this is a huge difference, don't you? They were not the same at all, right? Okay. And also, if the second one was looking as the best option, because start with the smaller table, it actually doesn't work well. It's failing. There's all the calculation. If I have to show you all the calculation, we will stay here until Fred's speech. But so trust me, that was coming up. And this is why we have hash join, actually, because why? This is why. Why we have hash join? We have hash join because in case like the first case, the first column here, that use an index, we have, this is coming from, from query, all the test comes from DBT3, and on each test I have reporting that when there is an exception or there is something to say, I report the query number, so you can go back and check and analyze what I'm saying. The data, for instance, if I use an index, the data used for that specific nested loop, index nested loop, cost 12 megabytes. If I remove the index and the same kind of block nested loop at that point that is going through the full scan will cost 1 gigabyte. So there is a huge increase of dimension and number of rows that needs to be parsed, right? And scan are able, we know that, and when scan takes place we have a block nested loop, and this is why we have hash join. That's to help us to prevent that. Now, with the new MySQL explain with tree, you can easily see when there is an hash join and what kind of things it does. Now, Eric already explained everything about hash join. I'm not going to repeat. Just brief mention, we have a lot of MariaDB people mounted itself. But I'm not going to explain hash join in MariaDB. I'm just saying using I called old MySQL iterator to differentiate to the new MySQL iterator, but it's a MariaDB MySQL iterator, classic hash join approach, equicondition subjoin, and different algorithm, right? That for the block nested loop. But we are interested only for the hash join. Now, I was not sure to show if I would show that, but I will. This is an image coming from MySQL showing the difference between in performance between block nested loop and hash join. But to me, this is misleading because that assumed and sorry, this also use dbt3 as test, and you can see the query on the bottom. I think this is misleading because it gives you the idea that everything works perfectly, much better using hash join, but this is true only when you remove all the indexes. And we know that dbt tests use multiple joins, and I don't think there will be one single DBA here that will remove all the index in production to do the to see if this is more efficient or not. So in my opinion, when we analyze these kind of things, we need to analyze the things removing maybe just one index in the join and see what is going to happen with a mix of nested loop for the index and hash join, okay? Which for me is more real than other situation. The test I have done for the baseline, I was using dbt3 with factor 1 and factor 4. Factor 1 fit in buffer pool, factor 4 doesn't fit in buffer pool. And MySQL 80819, PS 018, MariaDB 10.4.12, and everything was more or less configured as a default except the buffer pool dimension. I had adaptive hash index disabled, and the buffer pool, the join buffer pool to 1 gigabyte for one specific reason, because I don't want to spill on disk as much as I can, okay? Everything should be in memory. Now, from the first round of tests, what came up is that lower is better. And from the first round of tests, what comes up, this is against standard dbt3 with all the indexes, right? We have that db factor 1 and db factor 4 are more or less, the trend is more or less there. And what it seems is that MariaDB is going, is taking longer. Monty, stay there, don't worry. Stay there. Yeah, okay. But yeah, it looks like it's taking longer, and actually the sum of the time is higher, right? But if we start to analyze how many times this distro has been really, for real, more efficient than the others. So how many times MariaDB or MySQL has been more efficient than Percona and MySQL, we will see that we have almost an equal distribution. Just one query, two queries are different, right? And this is, so what's going on here? What is going on is that we have the two distributions doing more or less the same thing, except few cases. And this is for dbt3 test with the indexes. Now, the hash join run, I did only with factor 1 because I want everything in buffer pool. Again, I try to minimize the disk. Only few queries are relevant, so the ones that have very significant hash joins. And I also didn't kept separated per core and MySQL. They use the same algorithm. And interesting was that some queries were hung unless few changes, right? And the tests were done with buffer pool empty and then redone again with the buffer pool filled, because you will see what happened. And at first run, what comes up is totally the contrary. MariaDB is much more efficient than MySQL. The total time that is actually taken by MariaDB is less in executing the join. And this is interesting because that is for hash join total time, and with the base with the index we saw that there were some difference. Keep in mind that I was summarizing here not all the queries, but just the one that I also apply for the hash join. So the results are a little bit different from the previous graph. But again, if I start to count how many times was MySQL better than MariaDB, or vice versa, how many times MariaDB was better than MySQL, we see that with the buffer pool empty, MariaDB was 9/6, and the buffer pool filled was 8/7. So, guys, we are there, right? No? Okay. And again, why so? The query execution time, here is the buffer pool empty, tell us that, again, once more, the two distros are very close one to the other in how they perform, except few cases. In few cases, we can see that the MySQL run was dramatically worse than the one in MariaDB. And we have, for instance, query 19 that is taking much longer, or query 2 that is taking longer as well. And then we have a special case here that I will describe as an interesting case, that is the infamous query 5. And Eric, we have been working on that. Interestingly, when the buffer pool is actually filled, MariaDB is in some cases less efficient than before, and MySQL is able to gain a little bit of over it. But again, as we see, the query that were not correct, the query that were taking long, they were still taking long. And here we have an example. Query 5. With index, the query 5 takes 71 seconds in MySQL with a buffer pool empty, and 5 seconds with buffer pool filled. In MariaDB, takes 70 seconds and 4 seconds, 88. So MariaDB is better. MySQL take a little bit longer, but it's a matter of few things. It's not really too much. In a hash join, with hash join, we have that the first run is great. I can't believe that. Okay, the first run for buffer pool empty in MySQL take 447 seconds, and MariaDB 955 seconds. So MySQL is much better. But the second run in MySQL take, Eric, how many hours? Yeah, it's 47 hours. It takes 47 hours. Actually, I was killing the query and say, okay, I reported that to our guys, my friends. I love you guys. You know I love you, but it was 47 hours, and yeah, and the problem here was that actually the plan was changed by the optimizer, and it was not recognizing correctly a few things, and it was executing crazy query. In fact, in the first run the one with the buffer pool empty, we were having data read per join for that specific join only 129 gigabyte. But in the second run, when the buffer pool was filled, it was doing 4 terabytes data, just because it was reiterating and doing the thing, right? Wrong plan. Of course, there are ways of fixing this, right? And the one way, the trick to make it work better was to change the cost in the MySQL engine cost table to say, hey, this query, the cost of the query is the same either if you use memory or if you use the disk. Wait, Simon, wait. And actually it works fine, and it works fine, and the time at the end was acceptable. But obviously that cannot be used in production, right? Because you cannot change the cost model in production. You will screw up all your applications. Well, you screw up the access to the application. There is another case that I was mentioning to you, the query 19 with a hash join was, the query 19 with the hash join was, in MySQL, was taking 10 minutes and 57 seconds, and in MariaDB was taking 2 minutes and 70 seconds. But the interesting part here is if you check the plan, it's totally different. The plan from MariaDB was starting with the small table, index, blah, blah. The plan from MySQL was starting with the part table, using word, filtering, whatever. And it was not going very well.
I guess this is not query 19.
Pardon me?
I don't think you are on query 19 now, but those levels are two-table join.
I don't get it.
Oh, the number, you say query 19 on the slide, but query 19 is a two-table join, so I think this must be another.
Maybe you're right. I have the notes. If you want to let me fix that, I will fix. Doesn't change. The results are the same. Doesn't change.
The hash join was not used in there, I guess, right?
No, the point was the order. The point was the order, and actually was doing the nested loop exactly because it was not doing at the end what it should do. And in fact, if you change the join order and you set this exactly the same join order, well, actually it's still well, it reports as block nested loop, but actually if you do the plan with the tree, you see the hash join. But it's the difference is that when you're using the other plan, the plan will bring you to 2 minutes and 18 seconds, exactly the same thing that MariaDB was doing. So it was a plan. So what is at the end? So guys, that we are talking about 1 second. No, we're talking about 1 second here, 1 second there. What's the difference here? What that makes real the difference? Where the problem was is the optimizer. Okay, why? I'm almost there, I think, in terms of time, right? Yeah, but I'm checking. I'm 23 minutes, so I should stop. Yeah, all the time. I have the clock here. Okay, but for questions, I know there will be questions. So, so consideration. The problem here is that yes, the two implementations are they perform more or less at the same, well, similar. Okay, they are absolutely not the same thing. One uses one algorithm, another one using a different algorithm. One can spill to disk. We don't, in this test, I did not use the spill to disk having join buffer quite large, but of course, if I have a, I spill to disk anyhow, because sometimes the join that was bigger than 1 gigabyte, right? So it was not fitting in memory, right, Eric? So it was, in any case, use that. But I was trying to reduce in that. The point here is that changes are very minimal. What instead makes the huge difference is the optimizer. And the problem is that I don't think that we have the hash implementation talking correctly with the optimizer. My perception is that whatever we see here is because the optimizer needs to have a little bit more information in order to be more precise in choosing the right plan. How you guys can do it, I have no idea. But my point here is, as it is right now, we may have similar issues in production and affect the production, right? Much worse than a block nested loop that is known, it's already implemented, is there, it will take what it will take, but at least is predictable more or less, right? Is already considered. I'm not saying that hash join is bad. Actually, hash join is good. I'm just saying that we need to have a better way and better mechanism, a better way to provide feedback to the optimizer. And okay, the MySQL hash join with spill to disk is totally different conversation. It needs to have comparison, pairs with pairs, not with something different. And what else? Yeah, instrumentation. MariaDB, please give us a little bit better instrumentation to analyze the hash join itself, because the only way we have right now is to do the JSON, explain JSON, which is not enough. We don't have all the numbers that we may need. But
implementing a total new format like tree is hard. Adding more information, the current one is easy.
yeah, I don't care if it's tree or if it's JSON, just give us more detail. Yeah, and yeah, and the other thing is, in order to, given this feature, let's say it's still new, I would say, please give us the option to play around it, enabling, disabling, enabling the other, disabling the other for debug purpose. Because if you just force all of us to go in one direction, that will be a wrong things to do. I mean, we need the option to say, okay, use hash join, use block nested loop, use this, use that on the session, of course, but really to be sure that that is what is going to happen, right? That's it. Thank you. Question? Do we have time for questions?
Yes.
And yeah, I am not sure that I can answer, by the way.
It's a very simple question. You mentioned the, I think it was buffer pool full. I actually assumed when you meant that you'd actually loaded all the data to the table, but I think you meant something different. What did you mean by buffer pool full?
Filled by, okay, the question was, thank you, the question, can you repeat the question? I know. The question was what I meant when I was saying buffer pool full. I was saying buffer pool filled by the query, meaning that the query had already executed, InnoDB already read all the data from the disk and put the data as page in the buffer pool. So the next run, it doesn't have to go on disk, but just read the data directly from.
How did it get slow?
Pardon me?
Didn't one of them get slow?
Didn't? Yeah, no, the one that was going slower because the plan was changed and was ineffectively doing that. Right. Don't kill yourself. Yeah. But there was no concurrent joins. Just, well, wait a second. If I put a join buffer to 1 gig, I'm giving MariaDB some benefit because I'm giving you more space because they can spill on disk. While with MariaDB, if I understand correctly, the implementation, and please correct me if I'm wrong, if I have a smaller join buffer, and the other settings I never remember that is related to the join buffer itself, also the, well, yeah, there is another one that is correlated. So I give you the space, I give MariaDB the space to work as much as close as in memory, as much as close as the hash join. Yes. Yeah, no, that was on purpose to give, to try to compare apple with apple, because the implementation is different. No, okay, that one was a specific case, but on the others, I have, if you want, I can share with you my text file with all the notes, and you will see, okay? Any other question? No? Okay. Oh,
So you ran, when you filled the, so you ran the one query once, then you, on an empty buffer, and another time when you filled the buffer.
immediately after.
Yeah. So this was not the average of multiple runs, just one run.
One run, yeah.
Because I've seen that sometimes the query plan for MySQL kind of struggles a bit, because I think there's something wrong with the statistics in InnoDB, so it thinks there's less in memory than it actually is.
Fix it! Good, fix it! Yeah,
You can still submit a patch.
yeah, yeah. Okay, thank you very much, guys.
Thank you.